similar concepts in logic, to similar concepts in category theory, to similar concepts in type theory. 25. In logic, it's true. In category theory, it's terminal object /-2, truncated object. In type theory, it's H level 0 type unit type. 24. In logic, it's false. In category theory, it's initial object. In type theory, it's empty type. 23. In logic, it's proposition. In category theory, it's -1, truncated object. In type theory, it's H proposition, mere proposition. 22. In logic, it's proof. In category theory, it's generalized element. In type theory, it's program. 21. In logic, it's cut rule. In category theory, it's composition of classifying morphism/pullback of display maps. In type theory, it's substitution. 20. In logic, it's cut elimination for implication. In category theory, it's Kunit for Hom tensor adjunction. In type theory, it's beta reduction. 19. In logic, it's introduction rule for implication. In category theory, it's unit for Hom tensor adjunction. In type theory, it's eta conversion. 18. In logic, it's logical conjunction. In category theory, it's product. In type theory, it's product type. 17. In logic, it's disjunction. In category theory, it's coproduct -1, truncation of. In type theory, it's sum type bracket type of. 16. In logic, it's implication. In category theory, it's internal hum. In type theory, it's function type. 15. In logic, it's negation. In category theory, it's internal hum into initial object. In type theory, it's function type into empty type. 14. In logic, it's universal quantification. In category theory, it's dependent product. In type theory, it's dependent product type. 13. In logic, it's existential quantification. In category theory, it's dependent sum -1, truncation of. In type theory, it's dependent sum type bracket type of. 12. In logic, it's equivalence. In category theory, it's path space object. In type theory, it's identity type. 11. In logic, it's equivalence class. In category theory, it's quotient. In type theory, it's quotient type. 10. In logic, it's induction. In category theory, it's colimit. In type theory, it's inductive type, W type, M type. 9. In logic, it's higher induction. In category theory, it's higher colimit. In type theory, it's higher inductive type. 8. In logic, it's completely presented set. In category theory, it's discrete object/0 truncated object. In type theory, it's H level 2 type for set H set. 7. In logic, it's set. In category theory, it's internal zero groupoid. In type theory, it's bishop setsatoid. 6. In logic, it's universe. In category theory, it's object classifier. In type theory, it's type of types. 5. In logic, it's modality. In category theory, it's closure operator, idempotent monad. In type theory, it's modal type theory, monad in computer science. 4. In logic, it's linear logic. In category theory, it's symmetric, closed monoidal category. In type theory, it's linear type theory quantum computation. 3. In logic, it's proof net. In category theory, it's string diagram. In type theory, it's quantum circuit. 2. In logic, it's absence of contraction rule. In category theory, it's absence of diagonal. In type theory, it's no cloning theorem. 1. In logic, it's. In category theory, it's synthetic mathematics. In type theory, it's domain-specific embedded programming language.